Hey guys, so today we're doing lesson 6.1, day 2. How much do you get paid? Suppose you get a new job and your boss lets you draw slips of paper to determine your wage for the day. The wages are anywhere from $1 to $25. Um, and we're just going to pretend that this is the breakdown up in the graph of what everyone got. So 5 out of 22 got $1. 2 people got $5, 10 people got $7, 3 people got 10, no one got 15, and 2 people got $25. So our first question says calculate and interpret the expected value of X, which we know from the last lesson that in order to get that mean or expected value number, you take every X value and multiply it by its specific probability. So in order to get that, we would have taken 5 20-seconds times 1, 2 20-seconds times 5. So every probability times its X value and added them all up. In order to, once you would do that, you would get a value of that the expected value or the mean would equal 7.5, and it asks you to interpret that, which would be if we draw many wages, you'd expect to make $7.50. Pretty low wage rate. I don't know who's paying these people. But anyways, so it says recall from chapter 1 that the standard deviation tells us the typical distance from the mean. Complete the table to calculate the standard deviation for your probability distribution. So you learned in chapter 1 how to compute standard deviation. And so we take every X value and the distance from the mean we found to be 7.5. So you would do 1 minus 7.5 is a negative 6.5. And 5 minus 7.5 is a negative 2.5. 7 minus 7.5 is negative 0.5. 10 minus 7.5 is 2.5. And we're just filling in this little chart. So then 15 minus 7.5 gets you 7.5. And 25 minus 7.5 is 17.5. So then we take that value and, like it says here, you square it. And for this first one, negative 6.5 squared would be 42.25. And negative 2.5 squared is 6.25. And negative 0.5 squared is 0.25. 2.5 squared is 6.25. 7.5 squared is 56.25. And 17.5 squared is 306.25. So in doing these problems, you might want to make a little chart for yourself like this. So the first thing we did was found each distance from the mean, and then we squared those distances. Now it's a little different than finding a typical standard deviation. You have to actually weight those distances kind of like we weighted the means based on their probability. So 42.25, we're now going to multiply that by its respective probability. So 42.25 times the 5 20-seconds, because that would be its probability, that gets you 9.60. And then 6.25 times 2 20-seconds, which is that one's probability, that would get you 0.568. And then 0.25 times the variable for 7's probability, so 0.25 times 10 20-seconds is 0.114. And then 6.25 times 320 seconds is 0.852. 0 times 56.25, because that's a 0 probability for 15, that gets you 0. And 306.25 times 220 seconds is 27.8. And then from there, we need to add those all up. So similar to that typical standard deviation formula, you add those all up, which is 38.934, which technically would be our variance. You want to square root that to get your standard deviation, which is 6.24. So if you were wondering what that formula would be, that is going to be the standard deviation equals the square root of the sum of all your xi's minus the means times their probability. Oh, that guy's squared. And then you add them all up. So you square root it, remember, to get the standard deviation instead of having that variance. So that's how you find that. If you want a correct interpretation for that standard deviation, the wages will vary from the mean of 750 by about $6.24. So that's what the typical, how much it will typically vary from the mean. All right, moving on. It says Mrs. Gallus decides that she would rather assign wages to the employees so that they could get an amount from $10 to $20, and all are equally likely. So the key here is equally likely, and we're going to actually draw a distribution of this. So we have 10, and then you have $20 up here, and then so if we were to break that down into dollars, because this is still a discrete distribution, you could get 10, 11, 12, 13, 14, all the way up to 20. So you have an equally likely chance of getting all of those, and that's 1/10. So this, if you recall from past chapters, is a uniform distribution. And that's what that graph would look like. So like kind of like a box. So what is the probability that the employee will make between 12 and 1250? So let's estimate that. Like we'll say that that would be this area here in your box. So if we were to find an area of anything is length times width. So if we were to do that, remember the or height times width. The width here would be 1250 minus $12, which is 50 cents. And the height is 1/10. So if we take 0.5 times 1/10, you get 0.05, which would be your probability of an employee making between 12 and 1250. All right, let's move this along and scroll on down to basically the important ideas for today. The main thing was finding standard deviation, which kind of follows what you've done in the past. So let me zoom in on this a little bit more, and we'll write some notes down and then be done. So important ideas. Let's switch back to this. So standard deviation of a discrete distribution. So we have that the standard deviation equals the square root of the sum of your each x value minus the mean squared times the probability. Keep in mind that if you don't take a square root of it, it's called the variance. Secondly, let's talk about what's going to be part of your check your understanding. So if we're trying to find just a little recap, because we did this, I know, in way back in chapter 2, but it's something that's come up quite a bit along the way. Probability for continuous distributions. And that's basically just area under the curve, typical z-score. So if it's uniform, that's like what we did there. You would have some probability 1 over x, and you would have x on that side, and you would just have to calculate the area of that box. That's would be a uniform curve. Next, if you were to recall us dealing with a standard normal curve where you have the mean and standard deviation, remember your z-score formula. Oh, lights went out. Z equals x minus mean over standard deviation, and use your table A or normal CDF. So remember that's normal CDF, lower bound, upper bound, mean, standard deviation. All right, so with that being said, here's your check your understanding. I'm going to just go through this. Determining if this normal distribution is discrete or continuous, interpreting the standard deviation, finding that value. So just a little hint that this is going to be using your normal distribution because they tell you it's a normal distribution. So don't worry about finding standard deviation like we actually did in the lesson. That won't be any of the check your understanding part of this. So if you need help, remember to stop in office hours, and I will see you then.